this video, we're talking about the definition of like terms when it comes to addition and subtraction of like terms. So when we're trying to add or subtract, the definition of like terms is going to be the same variable with the same exponent. So in other words, if I have x squared, 3x squared, and 2x, and I'm trying to identify which of these are like terms, the first thing I need to do is look for the same variable, the common variable. So if I look in my first term here, I can see that I have the variable x. In my second term, I have the variable x. And in my third term, I have the variable x. So you might say these are like terms, but we're not done yet. We have to make sure that they all have the same exponent as well. So in my first term, I have x to the second power. In my second term, I have x to the second power. In my third term, I have x to the first power, right? This is an implied x to the 1. So what that tells me is that these first two terms here, x squared and 3x squared, are like terms because they both have an x squared. They are unlike this 2x to the first power. So when it comes to adding and subtracting, I can add these first two terms together, but I can't combine them with this third term. So here I have essentially 1x squared, and here I have 3x squareds. When I add one of them to three of them, I get 4x squared. And if I wanted to add this term, I can't combine it with the first one, so I just have to say plus 2x. If I look at my second example, I have x squared y p to the fifth. So if I try to identify my variables here, I have x, I have y, and I have p. I need to look for another term that also has x, y, and p. This one doesn't. It doesn't have x, y, and p. It just has x and p. So I know that these first two are not like terms. But this third one here, I have x, y, and p. So now all I need to verify is, do I have the same exponents? Well, here I have x squared, and here I have x squared. I have y to the first and y to the first, just that single y, so that's perfect. And I have p to the fifth and p to the fifth. So because I have the same variables with the same exponents, everything matches, I can add these together. I have one of these terms, 1x squared y p to the fifth, and I have three of them. When I add one of them to three of them, I get four of them. So 4x squared y p to the fifth, but I can't combine it with this term because there's no y involved, and I have this extra p squared, so it's not a like term. So I can say plus x squared p squared p to the fifth. Now if I look at a third example here, I have all of these terms added and subtracted together. I need to look for like terms to see what I can simplify. So here I've got an x squared and a y, I've got a y and an x squared and a y squared, an x squared and a y, an x squared and a y squared. So I see that really the only variation I've got going on is I have x's, and I have x squareds, I have y's, and I have y squareds. So let's look for terms where both of them are squared, where we have an x squared and a y squared together. Well, that's going to happen here. I have x squared and y squared together, and it's going to happen here. I have x squared and y squared together. So because of that, I know these are like terms, and I can combine them. I have one of them, and I have -4 of them. So when I say one of them minus 4 of them, I'm going to get -3 of them. So -3 x squared, y squared. Now let's look for the terms where we have x squared and y. So here we have x squared and y, x squared, y to the first essentially. And then here, even though I have y times x squared, we can use the commutative property to say that this is actually 3x squared y. I can switch the order of them. It doesn't change anything because they're multiplied together. That's the commutative property. So in fact, this term also is x squared y. So I have 3x squared y. And same thing here, x squared y. I have minus a 1x squared y. So when I add all these together, I have 2 of them, I add 3 of them, I get 5, I subtract 1 of them, and I get 4. So I'm going to end up with plus 4x squared y. And the only thing I want to change now is the order of my terms. So I start with a positive and end with a negative. So I have 4x squared y minus 3x squared y squared.